think it's on. Okay. All right. I think we are good. Let's get the party started. So, Kotlin today. I hope you're ready. I hope you're ready because the language will be quite a high barrier today, I'm afraid. But let's see what we can do. So, as a quick introduction, please remember that you can ask questions both on Zoom or if you are watching the live stream on YouTube, there is a live chat you can use. Right there is in front of you. Besides that, let me briefly introduce me. My name is Victor Renta. Did I share the screen? No, I didn't. Just a second. Okay, so 1 second to move the windows on my desktop over here. So here we are. And participants. Okay, 35 on Zoom and 11 on. Okay, so my name is Victor Renta. I am a Java champion. I've been coding in Java for 15 years. Right now what I'm doing for a living is doing trainings in different companies for different developers throughout the world. My main topics are Spring, Hibernate, Java 8, functional programming, let's see, the standard stack of development in Java. As you can see, I'm a backend guy, you can see that already. Architecture, domain-driven design, clean architecture, onion architecture, clean code, which is really my passion over here. Unit testing, test-driven development, Java performance. I just ended the training today on Java performance. Reactive programming, I'm having this training tomorrow for another 2 days, and secure coding. This is what I do for a living, besides conferences and meetups like I do with you today here. As a matter of fact, I have this community that I want to... All of this stuff that I'm doing today is basically because I have this community that I care very much about. Those of you who aren't yet in this community, feel free to join, it's completely free. And I'm doing stuff every month. I'm trying to do interesting stuff. The next one that I will do is consumer-driven contract with Pact. These are things that I learned myself, and I wanted to share what I learned and thus prove that I understood the stuff, share it with the community. Right, now, I do normally company training. I can also, I do also groups that you can join if you want. I also have some stuff recorded already on Teachable. It's all on my website. This costs money, but I also have a YouTube channel on which even this event today is already streamed and uploaded. It will be automatically there after it's finished, the recording. The meter that I mentioned, and a still young blog. That's me. If you want to reach me, this is my email, this is my website. Right. Good. So, let's get this party started with, where are you? Here. Let's see if we can handle Kotlin at this time of the day. Let's see. So, we have this little application of ours. Now, the setup is the following. Would you like your camera on? Yeah, keep the camera off. You know why? Because I normally want it open indeed, Gerard, but for this kind of events, keep it off because people typically keep it off. Plus, it's recorded on YouTube, so let me have the, all right, the honor, the horror. Good. Now, this is the simple application. I will, oops, what happens when I do this? It disappears all my, strange, I didn't know that. I think it's a feature of Windows. If you move that window, it clears the desktop or something. Anyway, just 1 second to find Zoom. Zoom is still there. Perfect. Now, I will discuss coroutines in the context of a UI application, even though I'm a backend guy. And I will do the parallels as we move further. We will start with a very simple application. By the way, the tutorial that I'm following, I pasted the links for you in the chat in case you want to watch that and want to solve it yourself. I would really encourage you to do that. It's a very nice way to learn Kotlin very deep if you do. The application connects to GitHub with a username and a token that I've generated previously, and tries to determine the contributors that are active in the Kotlin world. For this, if I start the application right now, it's using some code which is already doing stuff. As you can see right here on the bottom, the different repositories are scanned for contributors, and the contributors are summed up together in a set of this is the user, the GitHub ID. This is the how many commits, how many contributions he or she had to the Kotlin ecosystem. There are several bugs in here, but still it does provide some responses after a while of, let's do that again, of having a frozen UI. All right, if you ever code in a Android or a desktop application, you know what this is. You will just hang the UI thread. The thread which is supposed to be drawing the screen, you just froze it for the entire duration of your chain of requests. This is a terrible mistake that we will fix. There are several stages that we will go through today. But this is the first thing to start with. And let's first understand the code. We have this GitHub service over here, which you will, I'm currently calling yet org repos call. This call right now is written in a not very smart way, returning me a call that I can then execute. When I execute, this blocks the thread that I'm currently on. And I am currently on the equivalent of a main thread from Android. This is from a Swing application. I am on a thread which is supposed to be drawing the screen, to repainting the window. Right, so I just froze the UI because I blocked the UI thread with networking, with doing blocking remote calls. All right, so I execute. After that, I log the repositories that I got back. By the way, for those of you that are new to Kotlin, this it over here is a placeholder for the parameter of this lambda. And lambdas are surrounded by braces. So even if I write this, or if I switch to it, basically it's the parameter of this lambda in this case. And then I call body, which basically gives me back repos, which is a list of repositories. Now, there's all this data over here, these repos, this stuff. This is already written for us, fortunately. So the infrastructure is already there. I will skip I'm not interested in that really. What I want to see next is that starting from the repos, from that list, I do a flat map. Flat map takes a lambda over here. This lambda, starting from a repository, goes and fetches the repository contributors for that particular repository name, right? From that organization, Kotlin in our case. This returns back, this baby over here, returns a call, which I then execute, blocking again the thread which is supposed to draw the screen. And then logging the users, which basically provides these log entries over here, and then body list, returning me a list that I return from this lambda. This lambda returns this list over here, which is flattened with the contributors for other repositories. So basically, if you think of it, I'm iterating through some repositories. For each repository, I produce a list, and then I concatenate the lists to one another. Right, and then I call this aggregate function, which we have to see this before we continue. These are extension functions, something that are really very extensively used in Kotlin. This aggregate function is a custom function which is not yet implemented, which is supposed to aggregate the users together. Let me explain what that means. User right now has two things: login and contributions as integers. If you look in the screen, you will recognize them, login and contribution as integers. The problem is that the same logins have contributed to different repositories. So when you call aggregate right here, this is an extension function. Let me put it on the second half of the screen. Okay, maybe it makes more sense like this. What you see until this point is the list of users, you see? Now, list of users. What I have on the right side is an extension function of the type list users, which is supposed to merge together the users. What this means is that in this list, if you look carefully, there are people who have contributed to different repositories. I'm not sure if I can find one very easy, but there are some of them which are repeating in different. Cybergenome was I remember from previous, like Cybergenome here, Cybergenome here. It's the same user ID. What I want to do over here is to merge them together. How can I do that? Let's start first with this functional programming experiment in Kotlin. Now, this is the list that I am calling the aggregate on. Now, what do I do next? On this list, I need to do a group by, saying over here that I want to group it by login. I can start with the user and extract the user login, or I could just directly type it login. We will need such knowledge later on today. Then, after you do group by, you do map, and you say, after group by, let's stop on just here. This provides a map from a string to a list of users. So basically grouping them by login. And then you do map, and this is something that I really love. Map over here can iterate over each entry in the map. How to say that? I am basically traversing the entries of the map. But the beautiful part is that I can actually decompose the entry into login, which is the key, and the group of users, let's say users. So basically this decomposes the map entry into its two components, right? Key and value, right? What happens next? I will instantiate a new user that carries the same login, but that carries a number of contributions which is equal to the total of the group of users that had that ID, because they are actually representing the same user ID, the same username. How to do that? Users.sum of, and then you can pass a lambda. Remember that lambdas are always encompassed in braces, and then summing the contributions of each element in the users collection. This over here, just make it clear, this is the list of users. And what I'm doing over here, I'm summing up these attributes of each of the element in that list. Okay, after all this, I need to make sure that I return, let's see if I remember correctly. Right. Users should be sorted in a descending order by their contributions. So then sort by, should by descending, even better, by its contributions. It is the element. Right. If I done it correctly, when I will restart the application, I should see now a result which basically, first of all, the users will be sorted descending and their contributions will be added. Let's see if I got this first straight. Okay. We are still far from coroutines, I'm just warming up, right? This is a blocking flow that hangs my UI. Now, look, Schengen, Cyber Juno, told you, these are really 1,000 contributions. Okay, my respect. Schengen and so on. These are the users brought from the GitHub API. Now, next, we'll actually start refactoring the same solution over and over in different styles. The next challenge will be to make it happen in the background. What does it mean to do it in background? Let me just a second to split the screen. Perfect. And background. Background means that I should not hang the UI while I'm loading the users. This should not happen anymore. Now, the first solution to that, the first solution was to pass a callback. Now, this load contributors background is passed a callback. This is the lambda, this is a callback which is passed. Look at the code in here. This is the function. This is the definition of a function in Kotlin, returning void and taking a list of users to display in the interface. This is a callback, which I am implementing here, which is implemented here by updating the results in the grid in the UI. And this baby over here ensures that you move your execution on the main thread, on the thread which is supposed to be drawing the screen. Right. But the first thing you need to do is to get out of that thread. You come, when you click on the button, you are by default on that thread which is supposed to draw on the screen. So you have to exit that. And one brutal way to do that, don't tell me IntelliJ crashed. Really? Okay. Commercial time. Let me put some commercials. Yes, a bit more wrong. Rock music. Yeah, I'm also, as you can see, but I'm not sure it's okay for everyone. This one is, I will, now it will be indexing for the next half of hour. Let's hope it's coffee time. Yeah. I approximate, My guess is about 1 minute until I am up and running. Maybe 40 seconds. Let's see. Background. Right. Okay, let's see who calls this function, and I'm almost on track. It crashes faster. Yeah, it crashes faster on rock music. Yes, yes, yes. All right. I've never seen IntelliJ crashing before. Oh, never in my life. I never did that. No, never, never, never. Let's see. Crashed 3 times today. I was teaching performance. It had good reasons to crash. Right. So, let's see if I can find where this is called and continue the discussion. Really sorry for this incident. Still hang. All right. And come on. You can do this. You can do this. I'm sure you can. Come on. Almost. This is it. It doesn't open. Oh, the other one. Just a second. Here. Okay, that's it. Perfect. Now, I hope it won't happen again. I can't promise that, but what happens there? Yeah, when I say background, I am passed a function that will be able to display. This is the so-called callback style. Now, I did start it in a separate thread. This is what thread is doing over here. It's a function that starts this lambda in a separate thread. But when this is done, when this blocking function returns, so what, let's make it very clear. This is the set of users over here, users. When the users are back, I need to update the results. Update results. Passing the users out of this function on the callback that I am given. Basically, this will run at that moment. Let's see if I got this right. Yeah, this presentation is not original. Let's make it clear. It's not my work. I'm not a Kotlin guy. I've just used some official tutorial, hands-on tutorial that was shared on Kotlin Conf, which is public stuff. So I'm just taking advantage of what's already there on the net, right? Background. If I did it correctly, this should not hang the... Oh, wait. I can resize it while the stuff is still downloading, which is good. It has some lag, but it does resize it. Right. This happens now in background. This is a callback style. And if you ever worked with JavaScript, I'm sure you at least once had such callbacks from one success handler back into another function, and then this callback can turn into a very, very nasty style of coding, which is something that we ran away quite a while ago. Still, let's see. Callbacks. Just a second to make sure to understand what's over here. Okay, this one right now, it's does the same stuff, but on response. Wait, what's the difference? The contributor's callback, isn't it the same thing as this? I'm still taking a function as a parameter, as you can see over here. I have the same information in, but the difference is what? That I'm using this on response that basically does something a bit different, enqueues stuff. So this beats me, to be honest. This exceeds my understanding, but I can tell that this will not block either. Let's see it in action. When I change from these from one to another, I get to the different solutions in this place. This will not block the UI thread. This is true. What exactly happens over here? Let's start to read it. So, service, when the org repos call is back, then I register a callback after that is done. In that callback, based on the response got from, oh, all right, this is JavaScript, my friends. This is JavaScript. Based on the response that I got from that call, right, something like that. Something like CompletableFutures, indeed. It allows you to define a handler for when the responses are, the results are back. What happens then? I get the repos from the response. Then I create a list of users, which is mutable. Interesting that Kotlin by default, if you just say list of, creates you an immutable list. But mutable list is a sort of an array list under the hood. I think it's really the array list, exactly. Good. And then this array list, this mutable list in Kotlin, this type that we have over here, mutable list, overrode this operator. All users plus equal is an operator which basically enhances any mutable collections, doing add all. So this in a Java world would be all users add all, but written in a fancy style. I think this actually compiles, right? So this is imperative coding, as you can see, iterating through them, calling all, the contributors for each repository, and when those are done, in their callback, add to the users the new users, and then at the end aggregate the results. Now, the problem is that this doesn't report any response in the user interface. Although you can see the data being retrieved on the log, this doesn't update the user interface. And it's very interesting to figure out why. Just think of it. When does this line exactly work? Let me help you. Log, now I set the results in the grid. Let's restart the application. Just be very careful here. What do we have? We have a callback on the first call to get the repositories. This callback executes all this logic right now. It launches in the background some contributors call for each repository, registering callbacks to them, but then it immediately sets the results, as you will see in a couple of seconds. Here, if you say callbacks, load, bang, it's too early. I don't have the results yet. You see? I'm trying to update the user interface before I got ever some response back. So this opens the door to some problems. Where would you do that? Well, we could try to move this into the callbacks of the inner retrieval of users. So how does this feel? I get the repositories. For each repository, I call to get the contributors for that repository. But then when these are back, when the users are back, add them to all users, and then update the results in the interface using all users aggregate. This might seem a reasonable approach. Let's see what happens. If you followed carefully, you can feel the bug already. This is a callback for getting the repositories, right? There will be like, I don't know, 60 repositories. Then for 6 repositories, I will launch in parallel this piece of code. Whenever the response will come from either of those 60 repositories, I will try to update the user interface. Every time. Let's see if I got lucky this time. I got lucky. Let's try again. What did I say? Lucky? Why lucky? Boom. What the heck is this? A race condition. A race bug. It happened only the second time I pressed the button. What's the reason for that? When you do this for 60 repositories, you start 60 calls in parallel. When they come back, each of them will try to do the same piece of code, which will access a shared piece of mutable data. This mutable list is a shared piece of data which is written to and read from 60 parallel callbacks that can happen at any moment in time. And this is what led us to the errors. When I was calling these endpoints, at some point I tried to update from 2 threads the same array list, which of course doesn't work. Right? It's so nice. The default Kotlin are not trusted, but the default collections would be immutable lists. That could still lead to problems, but not concurrent modification. You might lose updates. Actually, at the end, you might lose updates if you do that. You can still do this, but it feels a bit awkward. This is how you, I think, you concatenate the stuff, but it needs to be a var. And this might lead to other problems. How to prove that? It's a bit tricky. Let's see how many results I had previously. I had 60-40 rows. Anyway, this is not coroutine, so I will skip away from this. But it's a race bug that happened to us. Let's just do one more try. 60-40 lines there were. Let's see how many I get now. I got lucky. But you are playing with fire over here. Let's go to the next one, which is really where we want to go, to suspend functions, to see how this looks when you are using coroutines. Now, up until here, we were using GitHub service over here. This service had this get repository, not contributors, the first one, get the repositories. Now, this returned me a call, which in Kotlin is opens the door to blocking invocations, remote invocations. Let's switch from using a call to using the default, which is used which is a response. In Kotlin and in Android world, you will use response from retrofit to get the response, if I remember correctly from what I saw in different teams. Response over here, response over here. This response over here allows me to mark these two functions as suspend function. Now this is where the magic starts. Am I right? Let's see. Suspend, I wiped out the, that's it. These are suspend functions, telling in the syntax that these might block, basically speaking. And I don't want to be blocking technically, but let's see what happens. Now, I am myself in a suspend function. Since my function can also suspend the execution, suspend the execution means not blocking any thread, but pausing the execution is the best example the best analogy. In an image, you will fetch the users, you will launch the network thread, and that coroutine green here will pause until the responses are back, and freeing that thread to do other stuff, such as drawing the screen. So I could start this coroutine from the main thread, pause it, free the thread to do the drawing of the screen, and when the results are back from the network, I can resume the coroutine. This is how it feels. Okay, let's see it in action. I will call this stuff over here, putting it a val. I'm not sure if I do a val here. This returns me, not call first of all, it's response, perfect. Now this, I need body list. I need also, do I have an also over here? I don't have an also. Let me just check one thing. Also here, I don't. Also, I want to log the same stuff that I did previously. Let me copy paste from that. From the first one. That's it. This stuff I want to do. Almost. Mess something up here. This. In my suspend, this. I'm logging the stuff. I'm getting the body list, which returns me a list of repositories. And I get a value of a list. This is a list of repositories. Nothing fancy. And I forgot to pass something here. The org. That's from the request org. Okay, good. This repos is a list, and then I will do repos for. Okay, plain old for. And let's try to use the same style of coding, the same imperative style of coding that we are so used to in Java. And that's actually the main benefit of coroutines. Allows you to use the same mindset, imperative mindset, all users. And then what? And then service dot get repo contributors on the request org, comma, the name of the repository. Then the same stuff also, I want to make sure I log the stuff in the console, log users. I need to pass the repo, and then the response, it, which is the stuff that I have as a parameter to this lambda, and then body list. What I get back from this is a val, which is a list of users. Cool. What do I need to do next is just all users plus equals about the list. It's a bad name. Body list, this is users. Perfect. At the end of all this, I need to return back what? All users, but aggregated together. Let's not forget to aggregate them together, because there might be different contributors, I mean the same contributors to different places. This is imperative coding, my friends. This is calling a function which will pause the execution of the coroutine. I clicked on the wrong button. Just stop this. One more. Suspend. Load. And the test, the ultimate test is to, yes, it resizes, even though I am still waiting and loading contributors. And as you can see, I am still on even queue. I never left even queue. It's only that I never blocked it for calling a REST an endpoint. I've just paused the execution of these coroutines. How this works under the hood, it's incredibly awesome. It's using a state machine. I was reading about this yesterday. State machine coroutine, really amazing. So the compiler does for you an incredible stuff, really. I was reading and crying, like, what the hell, really? Let me see if this is one. This is the one I'm looking for. Just a second. It's not the one that I did you see. I will try to paste it afterwards. Anyway, the compiler adds a lot of code in here under the hood for you to be just free of these problems. Now, let's see the next exercise. What if I want to do the retrieval from different repositories on different threads, on different coroutines, in parallel? So let's copy paste the code that we had already, and let's try to make it such that here, when I fetch the contributors, I fetch it in different threads. Not threads. This is my Java background screaming over here. In different flows, different coroutines, parallel coroutines. How can I do that? Well, the start is the same. The problem is here. Now, because this will very soon become parallel, I'm not allowed to use mutable list anymore, because this will lead to race conditions like we saw previously. So instead of that, let me first convert this into a form which doesn't use mutable collections. How can I do that? Well, it turns out that what I'm doing over here is just to iterate through some items, resolve every item to a list, and then concatenate the lists together. So if you think of it, this is like iterating to the repo, doing a map, actually, to be honest, a flat map, because I will join the results at the end, starting from a repo, and then the rest should be pretty much the same, with the only difference that at the end I need to return the users, which of course makes the variable useless. Oops, what did I do? I just need to cut this part out. And this will technically return me, if you evaluate all of this expression from here to here. Why am I not able to do that? Just a second. Did I forget to close a bracket or something? Let's make a val out of it. Here. This is all users. Yeah, am I right? Let's see. This is a list of users. Yes. It's okay. Now, all users aggregate will be the results. I don't use any mutable list anymore. I switch to a functional style. Yeah, indeed. So race, as you said, Gerard, you can still have race bugs. So you should first switch to a functional style of using just immutable structures, immutable collections, and only then move forward. Okay, what next? Well, if you do just this, it will behave exactly the same. I didn't change anything. The magic happens now. You see, when you are in this flat map over here, this piece of logic, you want to run it in different simultaneously. The best measure we will have is the loading time. Right now it's 20 seconds. Keep this in mind. I want to make it in parallel. Recoroutines, that's the magic word. If you don't have it here, nothing will work, as you will see right now. So let's start from the first. This is the function we had previously. But now, you want in the middle of this piece of logic over here. By the way, I need to point out one thing. This is an expression returning a value. You all realize this, right? And this value is the result of this lambda. All right. This piece of expression over here, I will wrap it in an async. But this async extension function is not available unless you are running in a coroutine scope, which I do right now. Now, this, my friend, is insane. Let me just, 1 second. I think, no, what did I do wrong? Let me see. Async. Did I close all the brackets? Yes. Deferred. Oh, yes, yes, almost. Async doesn't give me the results. No. Async gives me, let me show you, some deferred. Let's see if I got this straight. Almost. What is the type of this? Yeah, I need to do a wait, but not here, right? If I do a wait here, I ruin everything. I want first to collect all of them. Or I need to start all of them. Let's start with this one first. Await. Now, this async await over here should move you to run on a different place. Let's see if I manage to start it in parallel. Await all, yes, that's what I need, but I want to get there slowly. If you do this, as we have it right now, flat map, this feels like this. It's like you are starting an asynchronous processing, and immediately after you are blocking. This is a bad practice, as demonstrated by this. There was a best practices about using coroutines. If you ever find yourself doing async and immediately after doing await, that's a codesman. Let me async immediately by await. This is a problem. You don't want, because if you do that, nothing really happens. You just have to wait for the coroutine to finish. You don't parallelize yet anything. So if I run this now, you will have the same 20 seconds with concurrent. This is what I'm running here, concurrent, load contributors. But it's like firing the coroutines one after the previous one finished. It's not what you want, really. You want to wait all as Rizwan points out, but Rizwan knew this already, right? So let's see. The time should be also run around 20 seconds. Let's see, 70. Now, it didn't yet happen in parallel. The solution to this is not to await after every of it, but after here, am I right? Flat map, let me start over. Repos, async, and then what? It's not flat map, that's the point. Because this lambda doesn't return a list yet. It returns a deferred. I've just transformed the list of repositories over here, the list of repositories, into a list of deferred list of users, which is what the async gives you back. Gives you deferred of the response. What I need to do next is, as you say, await all, which is again an extension function which looks criminal if you look at it. It's a collection of deferred of t. What the heck? Any collection of deferred of t will basically await all at once. It's like a barrier if you want. It's like a join in a fork join pool. You are waiting for, it's like a zip if you are in a reactive world. It's the zip operator over here. Am I right? It's a zip, or sort of a zip, or a flat map. It's a flat map, actually. Right, await all. After I do this, this is, wait a second, if I make a variable of this is all users. Am I right? Let's see. Not yet. All users over here, I rushed. What I have here is a list of list. Flatten, which gives me the list of users. Finally. Wasn't that very easy? Flatten is basically a list of lists in a single list, concatenating. That's it. Let's give it a try. Of course, if you can be geek and you can inline everything together, and I have this feeling that the Kotlin developers tend to be quite geek, and I'm pretty sure this is how the code will look in the end. Okay. Maybe even worse. Oh yeah, why not? Let's kill them all, make them suffer, right? But no, I'm the clean code maniac over here, right? So I want, if possible, please don't do that. I'm the guy that I will create here all users. Maybe I'm old, I don't know. Good. Also mind that you are here in a lambda. I'm not sure if you see this. You are in a lambda. So the last line in this lambda will return the value, which will be the return of this. And by the way, what the heck is this? This function is equal to. This wasn't like this before. You remember? It was a definition of a function like usual. But now, equal. Now what the heck is this? This coroutine scope basically executes the lambda that you give it. Here, this is a lambda. If you look at it, this is a lambda that takes nothing and returns a list of user in my case, but executes this function in the context of a coroutine, which allows you to use async word here. If you weren't in the coroutine scope, you can't do that. So this is like a helper function that puts you in that opens for you the ability to start separate async flows. Let's see if I manage to do it. Concurrent load. Would I get less than 17 seconds or 20 seconds? Is it now in parallel? 5 seconds. From 20, it's quite good. And it's still, okay, it's not imperative coding, it's functional coding, but there are no, okay, it's not easy to understand, to be honest. Coroutine scope, you could do, yes, I could do coroutine scope dot, can I? Yes, I can. I think the semantics is a bit different in this case. Wait. Have to call that function. Nah, no. Like this, I think. This would work. This would work. Anyway, it's a different semantic in this case. Let me see what's advanced. Await suspend still gets the response. Interesting. The await all wouldn't work in this case. I will leave as an exercise for you to play with all this. It's really interesting to start from here and play different solutions. But the next one is really interesting. Not cancelable. Let's see what this means. The next request, let's start from this because we worked quite a lot of it. Let's try to make this flow, but not cancelable. What does it mean, not cancelable? Let's first see what happens if in the concurrent style that I have now implemented, while the contributors are loading, I'll wait just a couple of seconds, I press cancel. After I press cancel, nothing is ever, the whole execution is canceled, which is incredibly important for Android application. If someone closes your screen, you have to cancel all your background work. This is by default the behavior if you propagate this coroutine scope. So basically, you see what happens here. You are in a suspend function. Whoever called you had to call you also with a coroutine scope available somewhere for him. So let's see the example. Here, he was able to call the suspend function only within a coroutine scope. So it's like this coroutine scope over here, technically speaking, was propagated to this function, and I propagated further to the get repos contributors. It's like a chain of asynchronous, or a chain of coroutines, like parent-child coroutines, in a sense. Technically, there are jobs, but coroutines is good enough. Now, what happens after that is that launch over here returned him a job. This job was actually set up for cancellation, which made that when I clicked the button to cancel on the screen, it fired cancel method on the job. Okay, quite insane, I know, but technically speaking, this job over here has a cancel function. When this is called, the entire chain, an entire tree of coroutines is killed. This is interesting only in front-end development. In back-end development, I don't see this very useful. Still, interesting. Good. Now, coming back to my example, what I want to do now is to give up this beautiful propagation of cancellation, and I want to go to a place in which I make my flows timeouts. Yes, but you know how this would feel? It would feel like, yeah, it could. At the entry point of your processing your request, you can put a timeout saying that if the entire flow doesn't finish in 5 seconds, then you should cancel everything. Yeah, it could. For resilience, for putting a threshold on the latency of your downstream services that you call. Yeah, makes sense. Now, if you want to make something that runs without stopping, without ability to stop it, it's something very evil called global scope. This global scope will start this coroutine without, in a different, as you can see, I'm not running in a coroutine context here. I'm a plain function that in here somewhere magically gets from somewhere a global scope which is not cancelable. Those you can't kill. You can't kill those. They are like immortal coroutines. This guy in his best practices says that you should avoid using global scope because these are not cancelable, right? And this is a drama. It would be stupid to close them. By the way, for those of you that had no contact with Kotlin before, Kotlin is a de facto language today for Android development. So it will be very weird when you close a page in Android for the background requests to still work. It makes no sense. It will waste resources and battery life. So you should kill everything as soon as you can. So, not cancelable. I will load contributors, look at the log at the same time, and I will cancel when I see them coming. 3, 2, and cancel. And even if I press cancel, these are still loading, which is bad. So the default is okay. Okay, next one. Progress. Ooh la la. This will hurt. We are getting to more advanced stuff, slower and slower. Now, what's the point over here? This time, I want to have a better user experience. Me waiting for the grid to completely be filled up, it's not a very nice user experience. So for capturing the attention of the users, I want to progressively fill the grid with the data as it arrives. How can I do that? Well, it's a suspend function because it calls this org repos, which is a suspend function itself. Again, you can't call a suspend function except from a suspend function, right? So, or from within a coroutine context. Now, I got the repos back. I've started them, but this time, as you can see, I'm not returning anything. This entire function returns void. If you want, I can put this here, unit, which is the void in Kotlin. Doesn't return anything, so I don't return stuff. But instead, I will update the results. Now, to make things simple, I will make the execution in the same, on one single thread, if you want, in a single coroutine. I will not fork to different workers. I will keep on a single coroutine. Basically, going to the repositories with a map, calling that, which is a suspend function, body list, and when that is done, let's make a variable out of this. This is the users that I got. These users, I could do the same. No, I can't flat map like I'm using here because this would mean that I got the entire results back, which is not what I want to do. Instead, I will convert back from map. Not sure if you can do that automatically. No. Let's do a for. You can also cancel global scope if you save it. Yes. There are all sorts of subtleties that we don't go into, but this returns you a job. If I'm not mistaken, deferred. And this deferred has a cancel. Yes, you're right, Stefan. Very good. Good, but the cancel doesn't propagate automatically, as it did previously. Now, here I will switch to using a repos for, plain old for. Thank you. And I will call these functions as previously. Get back the users, almost everything. Thank you, users. Add them to an ongoing mutable list. Let's do that. Val all as the previous solution. Users equals mutable list of, thank you, user. Good. Add the users to all users with this overload operator. and then all users aggregate, and then this result, which is the stuff that I could already put on the screen, I will send to update results. Update results of this. Done. This should do it. Now, super important that I'm running in a single thread. You will see me doing a miserable thing right now. But first, let's test it works. But it doesn't. What does it say? Oh, completed. I have to keep track whether I completed the execution or not. For that purpose, I will switch this to using indexed. How do you do that? Indexes. That's it. Index. And I will see whether or not I am on the last index. So if index equal repos last index, repos last. Yeah, all of these are extension functions to the types we have. This is quite some mind. This is the biggest break in hard. It's hard. Okay, so progress, load. As soon as they will arrive, they will be displayed in the grid. This is what I want to achieve. There you go. Ooh, what a beautiful experience. Let's drink to that. Winnie Pooh. Good. Excellent. Excellent. So, it did with the work, the same 30 seconds. But now, what if I want to run these in parallel? Let's try that. Now, you've seen async previously. This async over here returns results. Technically a deferred that you can then await. But now let me do this a different style. This time, I don't need to return anything. But instead, I will use a different thing called launch. There are two things you can do from a coroutine. You can async execute some stuff returning you data, which is the equivalent of a callable, like submitting a callable into a thread pool, the closest equivalent, or launch, which launches a piece of code without it returning anything. But launch is not available unless you run it from a coroutine scope. Oh my god, that's really weird, huh? Launch should now become available. Let's see. That should do it. That's it. I'm moving now from a single-threaded process to a multi-threaded process. And I'm playing with fire. Oh yeah. Let's see. Why? Because I have a mutable list, and then I do a launch, and I change stuff in a mutable list from multi-threaded code. This time, I was lucky. Let's try again. Boom, there we go. Default dispatcher worker, boom, concurrent, the same stuff we had previously. Array list was changed in 2 different threads in the same time. By the way, one interesting idea here, you can move this to dispatcher's IO to get more threads than 8. Here I think there are 8 threads used. If you move to more threads, you can make it even faster, but it doesn't work because I got bugs. So let me comment this because this brought us bugs. And let's move to the last challenge, which is to do this multi-threaded. How the heck would you do that? Let's copy paste the code from here to the last one. And this is the creme de la creme. How the heck would you do that? Let's try. So I need what? To just copy paste the contents of this function. It's all recorded, folks. If you want to see it again, whoa, let's do this again. It's a bit insane, I know. I am now in a coroutine scope. Technically speaking, you could do this in a simpler way like this, if I'm not mistaken. All right. Now, I'm in a coroutine scope, right from the beginning, here, which allows me to call suspend function, but not that, allows me to do launch. But this launch over here has a problem that causes changes in shared mutable data. How can I fix that? Let's first make it compile. Oh, come on, isn't it obvious? Good. How can I make it happen? The solution for that is mind-blowing. It's called channels. Let me do it in your state. It's like a queue on which you can send data on one end and retrieve and receive data on the other end. It's like a queue. It's like a blocking queue, but without blocking. So, channel. On this channel, there will be users passing, technically speaking, list of users, because that's what I get, right? List of users, of user. Thank you. No, just this. And this is, here, thank you, a channel. Okay. This channel over here allows you to send the data on it. And what's very interesting here, instead of accumulating to any shared mutable state, the users that I got, I will send them on that channel like this. Done. Now I just sent messages on a queue. Imagine a queue like between applications or between just a queue, blocking queue, if you had experience with that. But then index becomes useless. But then what do I need to do? I need to await from that channel a number of messages. How the heck do I do that? I need to await how many messages, exactly how many repos are, right? If everything goes well, then I should get the same number of, let me do that. So if I recall correctly, for index in repos indices, okay, that's it, right? Which allows me then to do channel. Folks, this is mind-blowing. I know. Receive. How the heck call receive and what? That would normally block you, but will suspend the coroutine until the data is available. That will get you back the user from that repo. Oh, right. I think I did one mistake here though. I think I need to have both indexes and repositories, or nah, I think I need that. I just need the indices. Why? Because then I can, as soon as a user comes, a set of users comes, I will add it to the shared. I still have a mutable list of user, which is all the same stuff. It's still like imperative in a sense. Users, all users, add users, and then what's the difference from the previous solution? This time I am not calling update results from a launch or from an async, which will fork my execution. I will call it from the main coroutine, which is technically single threaded, if you want, in a single flow. All right. So all users dot aggregate. I think I should copy from somewhere here, and the same stuff over here. If I am on the last element, I should send this as a true. If I did right, it will work. Now, this is, to me, I mean, I spent about 15 minutes staring at this screen, several. By the way, why do we do this event? Because I learned coroutines recently. Some client of mine mentioned that they I have to discuss these with them. And since I learned them, I thought like sharing. And I was staring at this screen like, what the hell is going on here? Really now. It starts with a coroutine. It suspends the coroutine until it gets back the data from the repositories. Then it opens the channel like a queue. And then here, the coroutine never suspends when it calls launches. It fires all the requests for the repositories. And then immediately after does this, and then immediately after starts looping. And when it starts looping, it suspends only here in the receive, right? With context, yeah, okay. That's from an Android perspective. You could switch the context. I mean, this function that I am passed over here, something magic happens. Look, the function that I'm given is already switched on the main thread. This is what you meant over here, right? You need to move back on the main thread in order to draw the screen. So the function, when I call the function, the thread is switched from wherever I was, in IO or wherever I was, or back on the main thread, which is allowed to touch the screen. Which is super important in Android and any UI applications, not to change the screen, but from the main thread. Let me see if this works, and then I will answer Mihai. Channels, load. If that works, I should see results coming in as soon as they, yes, but I should see no errors here. And that, I hope, demonstrates I don't have a race condition. I can't know for sure unless I run for several hundreds of times and have, I mean, not seeing a race condition is no proof there is no problem in here. Mihai, if we would do another launch block inside, and now comes the question part. So please unleash questions, okay? Those of you who had experience with coroutines, I would love to hear your experience with them. So, Mihai, remember YouTube that you can use the live chat. If we would do another launch block inside of the dispatcher IO, here, will that thread pool be inherited, propagated? Well, if you do here again a launch, this, unless you do anything else, Kotlin and any kind of asynchronous framework in the world will try to reduce the number of hops between thread pools. So it will run in the same thread. Unless you request something specific over here, like for example, dispatcher's default, or you want to get back to main, or stuff like that. So unless you want explicitly, it will inherit the same. That's the beauty of it. But then there are interesting stuff happening here. For example, you can pass the job name, I think it's called, no, coroutine name. You can put debugging information in here, saying that this is sub stuff. You can add debugging information, and there is very good support for debugging this from JetBrains, of course, since they made the Kotlin language. So you can, for example, say get plus repo.name. And I think you need to put some configuration in here. Something with, let me cheat a bit. There was some very interesting debugging stuff that you can put. If you know it, paste it on the chat. Coroutine debug something. I think debug coroutines. Yes, that's it. So here there is a flag you should put in the GVM arguments. Let me check. Which displays the name of the coroutine that you are currently running, which is super cool. It looks like this. I won't lose time to. Wait. Here, it looks exactly like this, which is very cool to know where you are really running right now. Good. So it will inherit the same. Yes, an entire tree of coroutines will just be bundled together by the top coroutine. If you cancel this one, everything will die. If one of the children dies, everything dies. This is really very interesting. We didn't talk about exceptions here yet. It's just an introduction. Yeah, yeah, Mihai, but other questions come. So let me see, what did I miss? Okay, channels are called hot, while flows are cold. Okay. Flows are the equivalent of a flux in reactive programming. Flows are equivalent to a flux or observable. Channels are equivalent to a, not mono, technically speaking, these are like, as you say, hot indeed. You emit to them, but you can't lose emissions. The parallel is not extremely correct. In which thread do you receive on a channel by default? Is the one that you send? Oh shit. No, this is a hard question. let me. Ooh la la. The problem is that you are using the word thread. On which thread do you receive? If you moved yourself to IO, this will get you to this default dispatcher, which is the IO stuff. This one now executes your log users over here. This is the output of the log users on the worker thread 47. But then, when you get here, let me see that. if you do receive, you are now back in the coroutine scope that you started from. So I guess you are back on this thread. Let me check that. Log, where am I? Right? And I will see the results. Print line, exactly. Print line time. I think I'm back on I should be back on other queue. It's not necessary. Where am I? No, I am in the same worker thread that emitted. That's the beauty. You don't think in threads anymore. Why are you in here in 2, here in 28, you see? What the heck happens in here? To explain all this, I will need to go to get you through that implementation, how they are implemented under the hood. Is this the one? It was from nope. Yesterday. Nope. Nope. So it's really hardcore stuff here. How they were implementing. I'm not sure if I can get it that fast. It's a very complicated stuff with state machine. It wasn't Fibonacci. I keep saying state machine, but here it is. That's it. That's the article. Haha, found it. I'll paste it everywhere on all the channels that I have. Here is the article that explains in very great detail how these are really working under the hood. And there is a wonderful state machine generated for you. Let me put my finger on the state machine. Finally, there it is. My finger on the state machine. There it is. Very, very hardcore stuff. If you feel like breaking your head more, read this article. I should put it also on the community. Just a second to make sure I paste it everywhere. Otherwise I'll forget. Other questions if you have. The code that we wrote together, I will also zip it and upload it, but of course I can find the solutions on the Git itself. It has a solutions branch that I have inspired from, of course. I hope it was useful. And as a conclusion, I guess, some people believe that coroutines are better, they fit better the mind of an imperative developer, are easier to get to, are easier, and that's what this was a complex example in which I was calling like in a for. But in many situations, this is how the code should look if you don't want any fancy user experience. You call the order repositories, you iterate through all the repositories, and there you go, you fetch each of them. This is how the code in backend could look. There is no CompletableFutures, no then apply, no zip, no mono, flux, nothing. It's all code without any fancy chain of functions. There are try catches that work. Some people believe that this could be the way to go in the future in the GVM languages themselves, because Project Loom will be out in a couple of decades, which will add fibers to the GVM. And at that moment, GVM will have to take a decision. How will they handle concurrency when they will be able to suspend threads? For a backend dev, what do you return in a controller entry point method? You make your controller, I will play a bit. Done. And I've seen this code in some clients. Suspend functions, returning the results. You just ma on the response. What do you mean ma on the response? I don't know. Map. Yeah, you could map. Yeah, if you want to go functional, go ahead. There you go. Okay, that's a bit too complicated than necessary, but yeah. If you want functional style, feel free. But it still doesn't force you into a mindset of chaining functions ad infinitum, right? So it could be easier to read and maintain. Of course, it's Kotlin, not Java. And that's another huge leap you have to take. Now, I want to run a poll for you guys. Would you like to see a coding kata, a TDD coding kata in Kotlin? Those of you that survived until here, really, I really want to. So here you go here. And how do I do that in Zoom? Yes or not really. If you don't say like Kotlin is too wild, just say no and that's it. I'm curious how many yeses I get. Okay, yes. TDD is loved. Yeah, love. Excellent. Good. So a lot of yes. Then I will try to do a TDD kata. I have some other events scheduled first, but maybe in January. That's it. I don't want to keep abadi. I'm done. Thanks a lot for your attention. Hope to see you for another one. Feel free to reach out to me if I said some stupid thing. If I want to correct me or help me anyway, just email me and we'll chat. Thanks everyone. The recording is already available on YouTube. I will stop the stream in 15 seconds. Thanks everyone. Hope to see you for another one. Bye. Do it yourself, by the way. That's the best way to learn. Bye. End stream on YouTube and end.